Memory is something that we depend on every minute of every day. While short-term memory can help us remember the name of a person we just met 5 seconds ago, long-term memory enables us to recall an event that occurred weeks or even years in the past. But as we've recently learned in class, there are in fact 3 unique systems with memory: short-term, long-term, and sensory memory. Sensory memory, as defined by our textbook, briefly maintains our perceptions in a buffer area before passing them on to the next memory system, which is short-term memory. Experts have found evidence to believe that each sense, including hearing, touch, vision, taste, and smell, has its own unique form of sensory memory. Extensive studies have been conducted regarding visual and auditory stimuli, but only in the last several decades has the sense of smell been explored in greater detail. As we began our research, we continue to find ourselves running into studies relating to olfactory stimuli and short-term memory, but few studies relating sense of smell to long-term memory. In a study conducted by Dr. Philip Stova in the year of 2017, evidence was found to suggest that experimental groups exposed to the essential oils of rosemary and lavender have a statistically significant increase of the image memory, or short-term memory, than those of the control. In short, participants exposed to lavender and rosemary essential oils had far better vision short-term memory recall, or working memory, than those who did not. This, along with a love of essential oils, sparked our interest to investigate the effect of lavender and rosemary essential oils on long-term memory and biological processes. In a study conducted by researchers from Chulalongkorn University in Bangkok, Thailand, data indicated that after inhaling rosemary oil, participants experienced statistically significant increases in blood pressure, heart rate, respiration rate, also noting that they felt more refreshed. After inhaling lavender, however, participants experienced a decrease in blood pressure, heart rate, and skin temperature. We found these results to be congruent with other research that found rosemary to act as a stimulant and lavender as a depressant when inhaled by the body. Based on this research and knowledge of the physiological effects of rosemary and lavender, we wanted to test if an individual could enhance memorization over the span of 1 week with the addition of essential oils in their environment, and whether or not a stimulant or depressant would be more effective at doing so.
Our experimental study is designed to examine the effects of stimulant and depressant essential oils on long-term memory. We will select our participants from the population of Santa Clara University's undergraduate students between the ages of 18 and 22. We believe sending a mass email out instead of posting on Sona would be the most effective way for us to reach willing participants across all majors and years. Since we cannot force anyone to take part in this experiment, we will also ask professors to make announcements about our study in their classes and hang up flyers around campus to advertise it. In hopes of attracting more participants, we will also offer entry to a raffle for a $50 Amazon gift card as an incentive. Our goal is to have 60 students volunteer in total, so we can place 20 students in each one of our groups. Before our experiment, we will ask participants to complete a survey to pre-screen for allergies, identify their GPA and major, and provide other information unrelated to our actual study. After round 1, we will tell students that we are examining the correlation between GPA and choice of seat location in a classroom. We will also inform them that to be entered into the raffle, they must return after 1 week and fill out an information card. This cover story will screen for individuals with allergies and prevent students from studying the new vocabulary before they return for the quiz. Using a random number generator, we will randomly assign students to one of 3 groups as they sign up for the study. Our study will include 2 rounds. The first to introduce a set of 10 words and definitions, and the second to test participants' ability to recall these definitions 1 week later. In the first round, Group 1 will serve as our control and learn the words accompanied by no smells. Group 2 will do so with lavender-infused air, and Group 3 with rosemary. To spread the scent of essential oils, we will place petri dishes in each corner of the room and fill them with 15 milliliters of water and 10 drops of essential oil. This is the same method that Dr. Philistoba and his colleagues used to infuse the scent of essential oils in their study of short-term memory, so we know it effectively disperses the odors. We would do this before participants entered the room and would not make them explicitly aware of the presence of aromatics or what we are testing for. In this first round, one of us would introduce 10 rare words and definitions one by one onto a screen projector to each group. We intend to project each word for a total of 30 seconds after the instructor provides its definition. Some examples of our words and slides would be acnestis, the part of the back or backbone between the shoulder blades and the loins which an animal cannot reach to scratch. Obolus, which means the symbol divide, or xeric, a pinnacle or ridge of ice on the surface of a glacier. 1 week later, participants would return to the same groups to complete a short vocabulary quiz. During the quiz, Group 1 would again receive no aromatic treatment. Group 2 would again receive lavender, and Group 3, rosemary, the same scents as before. This will help us determine whether a stimulant or depressant has more effects on long-term memory.
In our experimental design, the independent variable we manipulate will be the type of essential oil participants are exposed to see if there is a change in our dependent variable, the quiz scores. They will take a short vocabulary quiz which will reflect how well they are able to remember what was taught to them the week before. The quiz will have a match the word to the definition format. To ensure that the participants aren't simply using process of elimination, there will be more definitions than words which will force them to actually think about the words and their corresponding definitions. We will calculate the mean of the quiz scores from each group in order to see which group has the highest scores.
We predict that the groups exposed to olfactory stimuli will have statistically significant better test scores than those in the control group. We hypothesize this because it is already well known that olfactory stimuli can act as powerful cues, evoking vivid and complete recollection of past events. We also hypothesize that participants exposed to rosemary will have statistically significant better test scores than those in the control and lavender experimental groups. We anticipate this will be the case due to evidence that suggests that rosemary acts as a stimulant. Therefore, attention will be increased and performance will be improved. In our analysis, we will calculate the mean test scores of all three groups and calculate the standard deviation and standard error of the mean. We will further analyze the data by performing inferential statistics in order to determine whether or not we would obtain the observed results only by chance. Although our study is very similar to that of Philip Stova and colleagues, our study analyzes the effects of rosemary and lavender on long-term memory instead of short-term or working memory. We specifically chose to use an experimental design so that we can observe the association between olfactory stimuli and long-term memory. By measuring against a control group, manipulating an independent variable, and randomly assigning participants to their groups, we eliminated confounding variables that might have influenced our data. The control group will allow us to properly compare the effects of lavender and rosemary to each other, and to normal college learning conditions as well. Since we will have participants return to the same rooms for their tests, we will ensure that a change in location will not affect the results. We will not know whether the context dependence on remembering the words also depends on learning and testing in the same location. If we were to change the testing location, there could be a potential for lower test score results. A possible weakness to our experimental design is our inability to test whether or not context dependence, in this case exposure to rosemary and lavender, is important during the encoding or the retrieval phase of long-term memory due to the presence of olfactory stimuli in both phases. Another weakness in our experiment is the lack of ability to generalize our findings to other stimulant and depressant essential oils. Additionally, we lack external validity due to our analysis of only one time duration studied. We also are only testing a small age range, that have college-age students. Our results may be different for those who are younger or older than our test participants.